I believe this is where we left off on Friday. Yes. So I believe this is the problem we left off on, yes? So the sum of the real numbers x and y is 25, and their difference is 13. What is the value of x times y? So the sum of two real numbers x and y is 25. So what we're saying is that x plus y is 25. And we're saying their difference is 13. And we want to see what their value would be if we multiplied them together, yes? Is f possible? F? Well, f could work, but what are the factors of 19? What multiplies together to give us 19? Well, 1 and 19, yes? Yeah. Does 2 divide into 19 evenly? How about 3? 4? None, because 19 is prime, yes? Yeah. So for these two here, the only way it would work is 1 plus 19 is 20, yes? Well, that's not 25. 1 minus 19 is negative 18 or 18. That doesn't work. So most likely, f is not going to be it because it's prime. Now, one way that we can do this is writing it as a matrix. Because we could say 1, 1, 25, 1, negative 1, 13. Do it as an augmented matrix, plug it into the graphing calculator to solve for x and y. So to plug it in, we can go second matrix, over to edit, hit enter. Now again, we have two equations and 3 spots. We have 2 variables and a number, yes? So we have 1, 1, 25. Then we have 1, negative 1, 13. Yes? Once we get it typed in, we can go second quit, second matrix. But this time we go over to math, and we're looking for our REF. We hit enter, pull it up. We can go second matrix A, and we get this here. So the x value is 19. The y value is 6. So x is 19, y is 6. So to solve this, we need to do 19 times 6. So the correct answer is J. Questions on any of this here? Are you ready for the next one? Yeah. I have no idea how to pronounce that. Teresa. That's Teresa. Teresa. We call her T. That's Teresa. Teresa. Yeah, Teresa. Hey, I believe we deserve a day off. Teresa. For knowing a word that you didn't know. How to pronounce it, yeah. No. Teresa decides to donate money to cancer research each year. Her brother Tony also decides to contribute. Together, they donate $1,000 per year to cancer research. If Tony is able to donate 1.5 times the amount Teresa is able to donate, what is the amount in dollars that Tony will donate after 5 years, assuming the amount and proportions remain the same? So how much? So $1,000 is how much they do together, yes? Now Tony, so we can call Tony Y, Teresa X. So Tony's amount is equal to 1.5 times Teresa's amount, yes? But the overall amount is what? 1,000, yes? So what we could do is plug 1.5 in for y to see what her amount is. So it'd be saying x plus 1.5x is equal to, what is x plus 1.5x? Almost. Yeah, so 1 plus 1.5. What can we do next? Divide 1,000 by? And 1,000 divided by 2.5, I think is, so $400, yes? And that's how much Teresa is contributing, yes? How much would Tony be contributing? 600, because we really didn't care too much about how much she's contributing, because the problem asks what? What amount in dollars that Tony will donate after 5 years, yes? Yeah. How much will they donate total in 5 years? 5,000, yes? So, well, 1.5, because we could have divided this by 1.5 to see what it would work out, or 2.5. But really, he's putting how much in total? 600 times 5 is what? So the correct answer is D. Well, now we could know that it's going to be more than 2,450 because half of 5,000 is what? So half of 5,000 is what? 2,500, yes? Now they would have both put in 2,500 if each one was putting in an even amount, yes? If they were both putting in the same amount, both were paying half of the $1,000 each year, then it would be 2,500, yes? But Tony is paying more than that, 1.5 times her amount. So we expect it to be more. Any other questions on this here? Was this problem easier than what it looked like? Yeah. A lot of the word problems, a good majority of them, not all of them, but a good majority of them, the word problems, the ones that are bigger like this, are easier than what they look. Because they're almost putting those in there to see, are you going to take the time to read it and understand what it's saying and solve it? One of the big ones that they'll use, and you've probably seen it before, they'll give somebody's name and then a cardinal direction. So Tony leaves his house and travels 15 miles or 12 miles north, and then so 12 miles north and then 16 miles west. How far is Tony away from his house in more or less terms? That's just a triangle. North, west, south, east, because we're talking about a triangle. 12. Yes. Well, 12 is just 4 times 3, yes? 16 is 4 times 4, isn't it? Y'all remember 3, 4, 5 right triangles? Well, they're just multiplying these all by. They like using 3, 4, 5. They like using Pythagorean triples. So if you notice that two sides of a right triangle are factors of 3 and 4, whatever that scale is, you multiply by 5, you get the hypotenuse. Yes? What to the power of alphabet? 1? Whenever there's not a decimal, it's 1. Any other questions on these here? No. Because I know we did this one here, or one like it. Number 8. A vending machine sells chips for 50 cents and candy bars for $1. If Jim spent $5.50 on snack in the machine over the course of the week, how many candy bars did he buy? So he spent $1 in snacks. So how many, well,
candy bars are $1. That's $5.
How many candy bars and chips did he get? Because if he just bought his, yeah, it's going to be K. Now the issue that we have with this here is, one, if he just bought as many candy bars as he could get, how many could he get? 5. That's not a choice, right? Now, the other stipulation we need, because we can say chips, because we can say 0.5C plus 1B is equal to 550, yes? But do we know how many of chips and candy bars that he got? Do we know any about the, because we don't have any restrictions on the overall total. So, I mean, we could have 4 candy bars and 1 chips, or we could have 3 candy bars, not 4, because this should be, because it could be 5 candy bars and 1 chip, or 4 candy bars and 3 chips, or 3 candy bars and 5 chips, or 2 candy bars and 7 chips, or 1 candy bar and 9 chips, or 0 candy bars and 12 chips. Because technically, by the amounts, all these work. But do we have anything that restricts us to one of these? No. That's why we don't have enough information to determine it. Or something saying that he had bought at least this number of chips, because he at least bought 2 bags of chips throughout the course of the week. Okay, well, the most candy bars he could have bought is 4, because he can't buy 5, because if he has 5, 2 bags of chips, that's out. So then we got more restrictions. We need more information. Does that kind of make sense? Okay. I think y'all are kind of getting the hang of how these work, yes?
Yeah.
A lot of this, especially with these here, is writing them out. Write out what they have and work from there. Now, that's it for here.